Hey, thanks for taking a look at absolute value equations and inequalities. There are three basic types: absolute value with an equal sign and a positive or zero value on the right. Here's an example. Now, absolute value of x minus 3 is equal to 5. That's only going to happen when the absolute, either what's inside the absolute value bars is equal to 5, or what's inside the absolute value bars is equal to a negative 5. So we're going to write the two equations, x minus 3 equals 5, or x minus 3 equals negative 5, and we do need the or. When we solve those two equations, we get x equals 8 or x equals negative 2. Either value would make the equation true. The graph is just 2 points, negative 2 and 8, and they're colored in. Here's our second example. We've got absolute value, and we've got a greater than sign, and then we've also got positive or zero on the right. Here's our example. The absolute value of x minus 3 is greater than 5. We're going to write this one again with an or and say either x minus 3 is greater than 5, or what's inside the absolute values, x minus 3, will be less than negative 5. See how we're changing that 5 on the right-hand side to a negative 5, and that's also changing the direction of the inequality sign. When we simplify both of those inequalities, we get x is greater than 8 or x is less than negative 2. And again, that or is very important. Our graph is going to have two parts to it, and it's going to have the arrows going facing out, and we have open circles here because we have just a greater than sign in our original problem. If it was a greater than or equal to, then we would have colored in those 2 points. And that would look like a greater than or equal to has an underline of the greater than sign. Here's our third example. Absolute value is less than a number that's positive or 0. In our example, I've got x minus 3, the absolute value is less than 5. Less than is different from the other two. We're going to use an and here. We need what's inside the absolute values is less than 5, so x minus 3 is less than 5, and at the same time we need x minus 3 to be greater than a negative 5. Again, we're changing the direction in that right-hand inequality. We're changing the direction of the inequality sign, and the right-hand side, we're changing to the opposite of what that value is. That gives us x is less than 8, and at the same time, x is greater than negative 2. Now, an easy way to write it without using the and is just to write a compound inequality, which sandwiches the values all together. So we have negative 5 is less than, so the negative 5 and the less than is written to the left of what we have up above where we've taken the absolute value off the x minus 3 less than 5. This gives us a one-part graph, and the part that's colored in between the negative 2 and 8 is sandwiched in between the two numbers. So that's a compound inequality. On all three of these types, we had absolute value, one of the three symbols, and on the right we had something that was positive or 0. When we look at the next values, we'll be having an absolute value expression isolated on the left, and what's going to happen on the right-hand side is going to be a change. Before we had either a positive value or a 0 on the right, and now we're going to be looking at what happens if there's a negative value on the right. Well, that's not it. Let's go down a little bit further. Here it is. Example 4. We've got absolute value of x minus 3 is equal to, and this time, see how it's different from that first example we had, we've got a negative value on the right. We've got something on the left that's always positive. We've got an equal sign, and on the right, something that's negative. That just can't be true. It's not possible, so we say there's no solution. And we could use an empty set symbol to express our answer also. There won't be anything colored in on the number line at all. Number 5 has absolute value of x minus 3 is less than negative 5. The expression on the left is always positive. The expression on the right is negative. If something's always positive, it can't be smaller than a negative number. So that's not possible. And again, we have no solution, and we could use an empty set symbol, and we don't color in anything at all on the number line. Example 6 has an absolute value of x minus 3 greater than negative 5. Now, absolute value is always positive. Something that's always positive is always greater than any negative number. So this is always possible. Our answer is going to be the solution set of all real numbers. So we can use big R, and we're going to color in the entire number line. So everything makes it true. Be sure to work the additional problems to reinforce these skills, and watch for another absolute value calculations using more than one absolute value, and also quantities with variables on the right. See you later.